we've just found the fraction of the tree trunk that's still alive. Let's call that fraction capital F. And notice that it depends on the current radius, r, and the thickness of living material, little d. We're now going to ask a second question, namely, at what rate does this fraction change as the tree grows? In order to answer this question, we're going to make some assumptions. So we're going to assume at first that the tree trunk radius grows at a constant rate, and also that the thickness, d, is constant. So we're going to answer the problem based on these two assumptions. Now let's first identify what is it exactly we're looking for and what do these assumptions mean. So the question is asking us something about the rate at which f changes with time. So in other words, we're going to be finding the derivative of f, but notice with respect to the variable t for time. Clearly, f is a function of the radius and the thickness, but in turn, the radius is changing with time, so f as well depends on time. Now, what do the assumptions tell us? The trunk radius grows at a constant rate. How do we interpret that? This is telling us something about r as a function of t. This is telling us that the rate of change of r with respect to time is some constant, which perhaps we can give a letter name such as a. So a is the rate of expansion of the radius of the trunk as a whole. Think of it growing outwards at this constant rate. We're also told that the thickness d is a constant. In other words, d does not change with time. D is simply going to be a parameter. And what we'd like to do is determine the derivative df by dt given these two assumptions.